microgrid. Microgrids, large conventional grid with high voltage power transmission. And then microgrid can be divided into several microgrid. As already defined, in microgrid, we have distributed energy resources and load that can be worked islanded or isolated or grid connected mode. And then inside microgrid, it can be consist of several nanogrid. Nanogrid, usually it is low voltage to serve just one building or even just small floor in one building. So nanogrid usually they have very low voltage, and microgrid usually low or medium voltage with no power transmission. So in Europe and in United States, they developed this kind of system to make the system more reliable, and then they have high resiliency, and also to use more renewable energy that get distributed near the load. The definition is not exact, so it is difficult to say. Usually, microgrid have power rating, for example, more than 100 megawatt. It is difficult to say about that because everything relative. But in general, it is like this. As already mentioned to you, that Indonesia, we have so many small islands. I'm sorry, this is still in Bahasa Indonesia, but it is easy to understand, I think. So we have so many small islands, and not all of the island is already powered by electricity. So the government, for example, they have target to increase the electrification ratio into 100%. But I think in the end of 2020, it is already more than 99%. But although the electrification ratio is already very high, but actually there are many areas that they get electricity not 24 hours, maybe just 6 hours a day or 12 hours a day. Because the problem is most of the electricity in small island, they got the energy by using fossil fuel. The problem, sometimes it's not about the price of the oil. The problem is how to send the oil to the remote areas. So that's why our government tried to increase the use of renewable energy that available in the area. So as we see that the lowest electrification ratio, it is located in this area and also this area. And it is sorry to this area because although the electrification ratio low, but actually in this area, they have so very large potential of renewable energy. But until now, because no transmission line developed in this area, we cannot construct a large power plant in this area. So microgrid technology is very appropriate for this area. And then, in addition to increase the electrification ratio, we have to ensure that our electrical system is sustainable electrical power. What is the indicators of the sustainable? We say that the power system is sustainable if the energy is generated, transmit, and distribute in an environmental friendly way. Then we have, it is sustainable if we can continuously reducing costs by improving efficiency and business practices. And of course, we have the continuity and quality of our supply. These three are the indicators of sustainable and power system. So, in addition to increase the electrification ratio, in Indonesia, we try to use renewable energy as much as possible. This one is the target of the renewable energy mix in Indonesia. So our target that in 2025, 23% of the energy must be renewable. It is the target in 2025. And in 2050, the contribution of renewable energy at least must be 31%. But to be honest, that in my opinion, that 23% target, it is really difficult. Especially now under COVID condition, it is really difficult to achieve 23%. Because I think at present, the contribution of renewable energy, it is just about 11%. So that's why at present, many actions from our government to achieve this target. Okay, at first, many people asking why the target in 2050, it is just 31%. Because many countries in Europe and also in America and some countries, the target in 2050 usually at least 50%. Even some countries, they have target that by 2050, the renewable energy must be 100%. So sometimes, why Indonesia target is just 31%? It is because of the resources or any other reasons. From the potential of renewable energy, at present, for example, from solar power, the potential of resources, it is very large. Yeah? It is more than 2,207 gigawatt. But at present, we just use about less than 1%. Also for wind power, we have big potential, but we use also less than 1%. Hydro, geothermal, bioenergy, we use less than 10%. So from the potential point of view, there are no reasons why our target is not more than 50%. So maybe there are other reasons why the target of our government by 2050, it is just 31%. So, for example, the main reason, for example, a very large portion of the renewable energy resources located here or here, but most of the load located in Java Island. And the problem, we have no transmission line connected the islands. So it is at present almost impossible to construct or to build very large power plant here. So in Indonesia at present, many PV or photovoltaic project, it is just small project. I think the biggest just 100 megawatt. Then, because to achieve the target of 2025, the target is to 23%, the government already have some action. At first, for example, providing various incentives. And then at present, in PLN, the state-owned electricity company, they have program that they call de-dieselization. That means they want to remove almost all diesel power generation in our countries. It is not only to increase the renewable energy electrification penetration, but also to reduce the subsidies, because generating power by using diesel is very expensive. Okay. And then the government also try to integrate as much as possible isolated grids. And then many action already done to improve the power system strength so that renewable energy, the penetration can be increased. And also promoting the use of microgrid system to improve reliability and resiliency. Now, until now, we have more than 600 microgrid using renewable energy, mostly solar power. So this is the position of more than 600 microgrid in Indonesia. And in this year, our government planning to install more than 1,000 microgrids. Yeah. It is excluding in this data, it is microgrid system that installed by telecommunication companies. Yeah. Actually, we have more than 2,000 microgrid. However, that microgrid is just supplied by using diesel power generation. So here, it is only the microgrid that supplied by renewable energy. As already mentioned, the microgrid can be AC or DC. Here, I show an example AC microgrid system. For example, here we have solar power, wind power, energy storage, and then first maybe we have also utility line or macrogrid. All of them connected through AC grid or AC bus. From here, we need DC to AC power. Here, we need AC to AC power. Here, we need AC to DC power. This one can be connected directly or through AC to AC converter. This one also can be connected directly or through AC to AC converter. In this AC microgrid, we need less power converters compared to DC microgrid. And then the main advantage of AC microgrid, the system is well standardized. However, in AC system, when we want to connect many sources like solar power, wind, and battery or utility, we have to synchronize all of them. The problem in remote area, because we have no telecommunication facilities, or the telecommunication facility that is very poor, then no communication among the converters. Because no communications, it is very difficult to synchronize. And then another problem, in AC power system, we have not just active power, but we have also reactive power. Reactive power will just increase the losses. And because we have this synchronization problem, we have reactive power problem, then by using AC microgrid, high power quality is difficult to achieve. At present in Indonesia, I think more than 90% of microgrid are AC microgrid. Then for DC microgrid, similar like AC microgrid, we have so many resources. But here, everything connected through DC bus or DC grid. Because it is DC, then we have no synchronization problem. We can achieve very high power quality easily. We have no reactive power problem. But the main problem of DC microgrid system, it is less standardized compared to AC microgrid. Moreover, we need more power converters. This is the advantage and disadvantage of AC and DC microgrid system. So that's why some people trying to combine AC and DC microgrid to take advantage of both systems. In DC microgrid, for example, here, we need DC to DC converters to increase the output voltage of the PV or PV module or solar cells. So usually we need step up DC-DC converter like this, or by using these converters. So in Indonesia, we develop this kind of DC-DC converter for microgrid applications. The DC-DC converter, it can be isolated or non-isolated. Here and here, it is the isolated version of DC to DC converters. Usually, this isolated version, it is used if the customer asking to do that. If not, then usually the manufacturers provide the non-isolated ones. Then also, we need an inverters to convert DC power into AC power. It can be single phase like this and three phase like this. Usually people, what they know, inverter, it is just an equipment to convert DC power into AC power. But with the advance of power electronic and the controls, I will show that an inverter can be operated as anything we want. So in the market, it is sometimes they call it multifunctional inverters or smart inverters. So in this case, for example, we have inverter here, we have DC, and then we have grid here. The output voltage of the inverter, it is synchronized to the grid voltage. If the output voltage is in phase to the grid voltage, and we control the magnitude so that the inverter voltage it is higher than the grid, then the inverter will generate the reactive power. If we control like this, then the inverter will absorb reactive power. That means, from the point of view of utility, if the inverter is operated like this, the inverter will be seen as a capacitor. In this case, the inverter will be seen as the inductor. If the inverter is controlled with the magnitude and angle become like this, then the inverter will produce active power with unity power factor, or absorbing active power with unity power factor. That means the inverter under this kind of operation will be seen as positive resistor, and this one as negative resistor. That means all properties of the component can be achieved by using the inverter. Even at present, there is a concept that people call as virtual synchronous generator. What the meaning of virtual synchronous generator? That means it is an inverter, but the behavior it is the same as conventional synchronous generator. So the control, the properties, the capability, it is the same as conventional synchronous generator. Then, when we are talking about microgrid, usually we talk about how to deploy the DC microgrid system. In Indonesia, at first, in remote areas, we have problem of lack of human resources. Who will install, who will maintain, who will operate? It is, to be honest, we are lack of human resources here. So automation, modularity, it will be useful here. The second, lack of communication facilities. So if we have many microgrid with many components, it is difficult to coordinate components or several microgrids. And then we have transportation problem. How to bring the equipment from Java Island, for example, to remote areas. Then also we have big problem here. In remote areas, sometimes the problem is not the price of the land. The problem in remote areas, it is not about the price, but who owns the land. Yeah, so it is sometimes it is not clear. The land is belong to whom. So it is sometimes this make a problem during the implementation. The last problem in deploying microgrid system is the load is scattered, not concentrated in one area. So it is the challenge of deploying microgrid, especially in remote areas. So because of this problem, we try to develop DC microgrid that, if possible, solving this kind of problem. Okay. So in my universities, supported by utility companies and some companies, we try to develop this kind of microgrid. So here, I have several towers. each tower, it is complete with PV module, with power conditioner system, with energy storage, and also an inverter. The inverter will supply several loads, or load cluster in SC form. Why in SC form? Because when we have installation in public area, we have to use installation that already certified, already standardized. The problem in Indonesia, electrical standardization is only applicable for SC system. So we use SC system when we are serving the loads or houses. Okay. However, here to integrate many PV tower, we use DC system, not SC, but we use DC. We chose 400 volt DC, similar to the voltage level that already proposed by several countries. Because it is DC, it is easy to integrate several PV tower. We don't need to synchronize the frequency, so we don't need to have communication system among the PV towers, and we have also no problem with reactive power. And then, because all equipment located in the tower, we are not using so big land to put the PV module or the power conditioner or the battery. So everything put on the tower. And then because it is just small system, it is about 3,000 watt for each tower. It is easier to bring from Java to remote area because it is not big and not so heavy. In the tower, in the PV tower, we have PV module, we have battery, we have many DC-DC converter, and also an inverter. So all of this, it is put in the tower. Okay. Nothing located on the ground surface. Everything in the tower. When we put everything in the tower, it is also useful to reduce vandalism. And then, because our government, we have target to increase the local content of the product, then the government asked me to develop our own power conditioning system. So for this purpose, we develop power converter that all of them have the same structure, although the application different. For example, this one inverter, this one is for battery charger discharger, this one for PV power conditioner, this one for grid controller. As you can see here, all of the converters have the same topology. By using this concept, we can reduce the cost of production of these converters. And also, by using this concept, when a converter broken, then we can use this, for example, actually it is converter for here, but we put here. So it is interchangeable. Yeah? So it is make the system easy to maintain and we hope that this will reduce the production cost. This is the pictures of the experimental system. So we have tower, we have 6 modules here, 6 panels, and then here we put the power conditioner system and also the battery. And in our experiment, we use 2 towers so that we can try or check the capability of the system to share the power. Of course, although we have only 6 modules here, when we need more power, then we can just use 2 towers and then connect it in parallel. And because everything put in the tower, then we don't consume so big land. So this is, for example, how the power sharing can be done. So, for example, in this tower, because of cloud problem, for example, no energy from PV. Then some power may be sent from here or maybe from here. Or if the battery it is almost the energy store it is very low, then also they can have power from here. The power will be shared to the other tower just by checking the voltage here. No need communication among the power converters. So the system it is easy to install and we don't need any communication facilities. The specification of our power converter it is 3000 watt. The DC voltage level inside the converters itself it is for 500 volt. But the DC grid voltage itself will vary from 350 until 390 volt. The AC output voltage to the load it is 230 volt, and the rating it is 13 amps, 50 hertz, single phase. So by using our proposed DC microgrid system, the system is modular, can be expandable easily. Customer receive power in the AC form. It is sometimes there are some misunderstood. It is true that almost all electronic equipment, like our laptop charger, it can be supplied by using DC voltage. But you have to know, although the equipment can be supplied by DC voltage, that equipment never be certified to be work with DC. The equipment just certified when it is supplied by using AC voltage. So sometimes the question is not it can work or not. Sometimes the problem it is certified or not. It is very important in Indonesia, especially if some accident happen, because usually the police will just ask you this installation it is certified or not. And then our DC microgrid system it doesn't need not need communication, and then no large land is required. Although our DC microgrid in the experimental system it is just using PV power, but actually we can use many kind of power sources. We can use micro hydro, we can use small wind power, and the others. And of course, it can be integrated into SC grid. So for the implementation, actually the research, it is funded by LPDP. It is a body under Ministry of Finance, and PTPLN, it is state-owned companies. So the system and the converter, it is designed by ITB. The converter, after designed by ITB, it is implemented by Sankan Electric Japan. And then the PV module and the integration into DC microgrids, it is done by BTLAN. It is also state-owned companies. At present, in cooperation with MIT, we are designing a robust and smart DC microgrid system to ensure stable, reliable, and efficient operation. So once again, I will show to you some poor area in Indonesia. For example, it is East Nusa Tenggara. The electrification ratio is very low in this area, but actually they have so big potential of renewable energy. Similarly, Papua, they have a very high potential of renewable energy, but until now, the electrification ratio it is still very low. Because it is connected with, consists of so many small islands or consists of so many small isolated grid. Yeah. So to solve the problem of electricity here and here, then I take the chance to improve not only in these areas, but Indonesia as a whole. So we propose the concept of supergrid. It is the opposite of microgrid. Supergrid, it is very large transmission system that interconnecting many big, large regions. If we can have this supergrid, power plant can be built directly at the source. And then a huge of renewable energy resources can be utilized. We can have sharing resources among regions, increasing renewable energy penetration without using a large energy storage, improving reliability and resiliency, improving environment, and the most important, it is distributing evenly in the world. So it is my dream in Indonesia, we have supergrid interconnecting many big islands. And it is only possible if we use DC interconnection, not AC. Why DC? Because many transmission line must be across the sea. So when it is by using cable and across the sea, then the DC is the only choice. We cannot use AC. And then if we have this supergrid, then we can build very large solar PV power plant here. Or we can utilize very huge potential of hydropower here. And we have also very large hydropower resources here. We have very large geothermal resources here. So if we have supergrid like this, not only the electrification ratio in this area can be increased, but this area it can be very rich because they have very large potential of renewable energy. And as you know, that the dream of supergrid is not just Indonesia. It is the global dream. So many people already thinking about the global grid. Grid interconnecting almost all of the countries in the world. And all of them, it is interconnecting by using DC, not AC. Because by using DC, the electrical system in Australia can be independent in the Asia. Because everything using DC and controlled by electronic. So in the future, the system, it will be consist of supergrid, mini grid, microgrid, and maybe nanogrid. The advantage of this, we can use renewable resources that may be located in near the load. And the most important for Indonesia, by using this microgrid combination like this, then if something happened to the supergrid, for example, during earthquake or any natural disasters, then the system still alive. So, of course, to implement the system, the grid must be smart and fully electronically controlled. So that's why the research on smart grid also increased significantly in the recent years. So, to conclude my presentation, a small DC microgrid system for powering remote area has been described. The proposed DC microgrid system is recommended for remote island and remote area. The proposed DC microgrid system has so many advantages, such as no communication is required, no big land is required, and many energy sources can be used. And the most important, it is modular. And if we can combine the supergrid and microgrid, it can be the key to achieve high reliability, high resiliency with 100% renewable energy. Thank you for your attention.
Thank you, Engineer Pekik, for the very informative session. I think, actually, while Engineer Pekik was presenting just now, I have to keep on rejecting new entries to this webinar session because we have already burst the allowed quota, right? So I think for the secretary to take note, maybe in future email blasts for our future events, okay? Even though, as a participant, even though you have registered, okay, make sure that you come in fast, okay? Otherwise, you will have to join us in the Facebook, right? Okay, so Engineer Pekik, I have a few questions for you. Okay, so the first question would be the how much percentage of the microgrids in Indonesia are connected to the main grid?
How much percentage? I think in Indonesia, most of the microgrid, it is isolated microgrid. Just very few microgrid connected to macrogrid.
Okay, all right, noted. Yeah, and then let's move on to the next question. Okay, based on Indonesia's experience, okay, how effective and efficient are renewable energy resources when used to power up microgrids?
Okay, to be honest, under present conditions, renewable energy is still more expensive than fossil fuel. It is the most important that we have to keep in mind. However, in some areas in Indonesia, because it is very remote, sometimes it is almost impossible, for example, to send diesel fuel to remote area. It can be weather problem or transportation problem. So the only choice in that area it is just using local renewable energy resources. So that's why to increase the penetration of renewable energy, our government concentrating on using renewable energy for remote areas, because only at that place renewable energy, it can be more economic compared to fossil fuel. However, because of that policy, until now, it is difficult to achieve renewable energy mix target. Because if we want to install very big PV power, then it must be installed in Java Island or in Sumatra Island. However, in Java Island and also in Sumatra Island, the production cost of electricity, it is already very low, because most of them, they use coal power plant. So, because it is already very low, it is difficult for renewable energy to compete in Java or Sumatra Island. However, if it is true, renewable energy may compete to fossil fuel in remote area, but the capacity cannot be so big. So that's why in national, totally, the contribution of renewable energy in Indonesia is still low. That is the reason. Thank you.
Thank you, Engineer Pekik. Moving on to the next question, which is also related to the current question. Okay. Currently, which renewable energy in Indonesia has the lowest cost of electricity?
Of course, if it is available, it is still the hydro. Hydro power is still the lowest, the cheapest. However, because of environmental problem, sometimes it is very difficult to get permission to build hydro power plant. So the reason, usually we have some conflict with environmental problem. Yeah, that is the first for hydro. But at present, we develop the use of biomass. It is not directly used for produce electricity, but it is for what people call as co-firing of coal power plant. So the firing of the coal, it is helped by biomass. So until now, by using the co-firing system using biomass, we already reduced about 10% of coal consumption. That is popular in Indonesia now.
Okay, that is very interesting to hear. Okay, next question is related to the PV towers that you have presented just now. What kind of battery that you use in the PV towers? What kind of battery?
Sorry?
What kind of battery that is being used in the PV towers that you have shown just now?
So in our PV tower here, it is the battery itself, it's lithium battery, and that it is polycrystalline PV towers, and the rest it is just conventional power conditioning system.
Okay.
So this is lithium battery. Why we use lithium battery? Because it will be installed on the tower, so we need high density energy battery.
All right. Okay. Moving on to the next question. Okay, actually the one who asked this question introduced himself, so I think I will introduce him as well. Right. The question goes like this. My name is Robbie Horace Padaman from Institute of Technology PLN Indonesia. So I want to ask whether is it difficult to install a microgrid, whether do you really need an expert to do that? That is because he heard that in the future it will be easy to generate energy from home. So what is your comment on this?
Okay, at present, not only just DC, even it is SC microgrid. The biggest challenge, as I told you, the first, it is lack of human resources. But another reason that is also very important in Indonesia, even the PLN itself, they have no fixed standard about the microgrid system. Because when we have so many resources, at present, it is not decided yet which power source has to maintain the voltage, which power source has to maintain the frequency. So, because no standard, then we have to treat place to place differently. That's the main problem in Indonesia. Another problem in Indonesia, usually microgrid project, because it is still expensive, usually it is funded by the government, by the Ministry of Energy. So it is project coming from the Ministry of Energy, and then built, and then hand over to PT-PLN. Sometimes, because PT-PLN not involved from the beginning, maybe actually the PT-PLN itself, they don't want to accept that system. Maybe PT-PLN accept that system just because PT-PLN it is in the hierarchy system, it is under Ministry of Energy. So, but finally, nobody responsible with that microgrid. That's the challenge of microgrid implementation project in Indonesia. That is answer the question. I'm not sure.
Yes, I believe so. Yeah. So we move on to the next question. I think the crowd today is quite active. A lot of questions coming in. Okay, probably because of the interesting presentation. All right. So the question goes like this: as independent DC microgrid to supply the energy, how to guarantee the safety of DC system and its reliability once the source is not available?
Oh. Okay, so as I told you that we have so many DC tower here, so several towers. So when the PC power in one tower not available, then we can have some power from the other sources. Yeah, so that's when the battery fail, when the PV power cannot generate power, then the load here still possible to have supply from other towers. That is the way to increase the reliability of the supply. And
so that means,
of course, it is possible to connect other sources such as DC power connecting directly to the DC bus. It is for the last defense when no power coming from the PV.
Okay, so what about
to ensure the safety? So that's why I choose SC system, because at present only SC system has safety standard. So we use installation system that already certified. Because if we use DC system for the housing, although as engineer, I can say it is safe, but because no certification body to certify DC installation, our government, they don't want to take a chance when something happens.
Okay.
So to ensure safety, I use SC for customer. To ensure reliability, I connect several DC tower in parallel.
Okay, thank you for the very clear answer. Okay, next question. For grid-connected microgrid, just now you mentioned that there is no standards currently, but is there any existing requirement or regulation in Indonesia?
So in Indonesia, we have a grid code for conventional microgrid. So when it is connected to the microgrid, as long as we can ensure that our microgrid will not disturb the SE microgrid, of course, it is by using some simulation or some study, then the utility company will allow you to integrate your microgrid into macrogrid. But until now, in Indonesia, we have to do some detailed study if the rating of the microgrid, it is more than 500 kVA.
Okay, noted for the answer. Okay, the next question is the, in case of the Indonesia super grid, okay, what is the main challenge to transfer the electricity using a submarine HVDC cable?
The big challenge in Indonesia, especially in east area of Indonesia, there are so many deep sea. Yeah, the sea is very deep. Yeah, that is the first challenge. The second, to be honest, we have no specific body that will give permission which area I can lay our cable. So sometimes we have to get some permission from many ministries, from defense, from energy, from environment, from anything. So to be honest, that is the biggest challenge.
All right. Yeah. So indeed, a super challenge for super grid.
Yeah.
Yeah. So okay. What about, okay, next question would be, so you mentioned that you have actually implemented your design of the solar system in your campus, I believe.
Yeah.
Yeah. So is there any lightning concerns, like for instance, any disturbance caused by lightning strike and all that?
Yeah, no, we already installed in some areas. Until now, only just one equipment already destroyed by lightning. So I have to improve the lightning protection system.
Okay. All right. Okay. So, okay, next question would be, it's interesting to see that one of your slides just now, you mentioned from the super grid and then to the microgrid, mini grid, and then microgrid, and then nano grid even. So based on your understanding, is there any standard demarcation? Like for instance, up to how many watts or how many VA is considered as micro, how many is mini, how many is nano? Is there any standard so far that you know of?
No clear standard. Until now, no clear standard.
Is Indonesia planning to come up with one so that maybe the rest of the ASEAN can follow?
Yeah. So in Indonesia, we now try to define that it is considered a super grid, for example, if the capacity more than 3 gigawatt. And then if it is between 3 gigawatt until 500 megawatt, we'll consider as macrogrid. Less than that, it will be mini grid or microgrid.
So is this already standardized? Is it published anywhere? Okay.
It is still in the draft.
I see. Okay. Next question would be, so when it comes to, for instance, a partial shading, okay, other than using the bypass diode, okay, is there any other technologies or method that we can use to alleviate the problem due to this partial shading?
So by using several modular tower, then we hope that when one tower is get some shading, then the power will be supplied by other towers. So just affecting one tower. That is our way to solve the problem of partial shading.
So there will be some.
Of course, it is possible to have some integrated converter integrated with the panel of the PV module. But in my opinion, until now, by current technology, it is still expensive.
I see, noted. Okay. All right. So, yeah, to the audience, do you still have any other questions? Feel free to type in. I think so far all the questions are very clearly answered. Okay. Let's check over the Facebook whether you have any questions there, because we also have some viewers there. Okay. Yeah. So. Okay, so that's the advantage of coming in early. Okay, then you can have the advantage to ask your question faster. Okay, so meanwhile, the handouts for the slides for the current webinar is already available at the handout section. Okay, so to all the participants, okay, please feel free to download the handout. Okay. So yeah, so this is maybe my question to Pekik.
Okay.
Do you have any plans to come up with the standards for this microgrid?
Yes, actually, I got a job from IAE to develop standard for DC system. So it is still in draft.
Okay, actually, that's the reason why I asked this question. So that you can at least announce it earlier so that we all can look forward to it. Yeah, okay, in fact we have one question here. Is there any standardized distance for each of the PCS tower?
So in my design, it is between the tower maximum 200 meter.
Okay, and yeah, there's also one more question. The system that you have developed just now, any plans to push it to be adopted at the ASEAN level? Making more people aware of it and for further deployment.
Yes, I hope so. Because as I told you that it is already implemented and all of them, the integration, it is done by PT Land. PT Land, it is a state-owned company. So I think if some countries want to use this system, they can contact me directly or contacting the land.
Okay. All right. So, yeah, I think we still have about 10 minutes. If there is no more further question, I think maybe the Secretariat can stand by with the PowerPoint. Okay, actually, we, on behalf of AEI-EI, we actually would like to really appreciate and acknowledge Engineer Pekik's time to share his knowledge, his experience, his expertise with us today. I'm very sure more than 150 of us, okay, around 50 in FB and around 100 here, has benefited from this talk. So, Engineer Pekik, I'm sorry that we couldn't hand this certificate physically to you, but I hope you can accept a small little token of appreciation. Yeah, also on behalf of Engineer Yao, okay, as the chair, he has to make a move earlier as he has some other business. So on behalf of AEI, I hope you can accept our certificate of appreciation. Thank you very much,
Thank
Engineer
you.
Pekik.
Thank you.
Yeah, thank you so much. So I think, yeah, so the slides is up there. And since there are no more questions, I think we can call it an evening or a night. And really looking forward to the next session. Okay, hopefully Engineer Pekik can also again speak. I think your session is one of the most hot so far. You can see that the participants keep on coming in, but we don't have the space. Yeah, and to all the other participants, okay, look out for our future events, our future talks, our future webinars as we continue to bring values to all the ASEAN engineers. Make sure that once you have received the flyer and all that, make sure you register fast. And once you have registered, make sure that you come in fast. All right. So, Engineer Pekik, do you have any last words or parting words to say?
Okay. Once again, thank you for giving me a chance to for me to share the experience, and I hope we can have a cooperation among the ASEAN countries to develop this kind of microgrid. Thank you.
All right. Thank you, Engineer Pekik. I'm sure when there is a vision, I'm sure it will be realized one day, okay, for the benefits of all over ASEAN. With that, thank you very much to Engineer Pekik, and thank you very much to all the participants for today. Looking forward to see you all again in our next session. Thank you and good evening. Bye.
Thank you. Bye.
Take care.